Here's some more examples of condensing logarithms. And again, the first thing we'll do is we'll put the exponents back. Now this is natural log, which means log to the base e, so this would be 7, This would be just natural log of x plus 4 to the 7th minus the natural log of y to the 7th. And now I've got the log of something minus the log of something, so I can say this is the difference of the logs, and that's going to be the log of a quotient, so I can write that as the natural log of a quotient. And I'm going to have x plus 4 to the 7th on top. And I'm going to have y to the 7th on the bottom. And that's it. Okay, let's try another one. Example 5, 2, natural log of x plus 6, natural log of y minus 4, natural log of z. Now these could be LO log to the base 3. It's just ln's a little bit shorter to write, but it's the same thing. So the first thing we're going to do is put all these exponents back up. So we have the natural log of x squared plus the natural log of y to the 6th minus the natural log of z to the 4th. And now I can combine these, and this will be the natural log of a product. So we're going to kind of do this first. You have to get some practice and experience doing these. You know, don't do these because you got a positive sign here. Well, you could do it like this, but you have to put a parentheses around it. And you could do it in that order. I guess it wouldn't matter. I usually go from left to right, so it always will work out the same. You just have to be careful if you're preceding something by a negative sign. You have to be careful. If you have a negative sign over here, you've got to be really careful. You have to use parentheses and change signs. It's a little more complicated. But in this is no issue here. Natural log of... So this is going to be a sum here, so I'm just going to do the sum first. That's going to be the natural log of x squared y to the 6th. So it's kind of like I'm doing this first here. And that's going to be my product. And then minus the natural log of z to the 4th. And now I've got the natural log or the log of something minus the log of something, so I'm going to apply the quotient rule. And there's going to be my quotient right there. That's going to equal 1 natural log. There's my quotient bar, my fraction bar, and this is going to go on top. X squared y to the 6th, and this is going to go to the bottom, z to the 4th. So again, we take care of the exponents first. Squared y to the 6th, z to the 4th, and then we can group these and we can do this product first and then this quotient. Now if you did the quotient first and then the product, you'd have y to the 6th over to z to the 4th and then times x squared. You could do it, you'd end up with the same thing. Okay? All right. And I got one more. This is example 6. Log to the base 10, I guess, of x minus 3 log to the base 10 of y. Okay? Now this isn't a log, so I really can't do anything with this number in front. But what I can do is I can take these exponents and put them back. So and I'll put this 2 up on the x, so x squared minus the log of y cubed. So we'll put that up there. And now I've got the, inside here, I've got the log of a, or the difference of the log, so that's going to be the log of a quotient. So leave the 1/2 out in front, but I have one log in here, the log, and this will be my quotient. Guess I really didn't need that. I'll just put it here since I already wrote it. That's going to be the log of the top, x squared. Or I'm sorry, x squared over y cubed. So the log of it, the difference of the logs is the log of the quotient. I got 1/2 times this. So now I can put this 1/2 up in front here. So now I can write the log of x squared over y to the third. And we really didn't need this parentheses here, but now we can put this 1/2 up here, so it's going to be the 1/2 power. Okay. Now sometimes we want to put that back into root, so that's like the square root. We've got the log here, so we could write this now as the log of the square root of x squared over y to the third. And now you condensed it. Now if you went backwards, you'd write this as an exponent. Then you'd put the exponent in front. Then you would take the difference of the logs, and then you'd put those exponents in front. So you can see how you could go backwards to expand it. That makes sense, I hope. Change this to an exponent, put the exponent in front. Change this to the difference of the logs, put those exponents in front. So you kind of see how it works both ways. So hope those make sense.